Hey, Stepsters! I'm Lasya.
And I'm Kritika, and we're your traders from Future Steps.
Today we'll be looking at exponents for grades 5 to 7.
Yep, so let's get started. So an exponent looks like this. A over here is going to be our base. So let me just make this into A. Let's have a number. So let's say we have 2 to the power of x. So 2 would be our base, and x would be our exponent. And every time you say it, it's going to be base to the power of whatever the exponent is. So like how I said, 2 to the power of x. Now let's talk about the rules. So we have a bunch of exponent rules that help us calculate during our question. So our rules over here is if a is not equal to 0 and b is also not equal to 0. Okay? So let's start off with our product rule. Our product rule is if we have two exponents with the same base that are multiplied, then the exponents will be added. So a to the power of x times a to the power of y would equal a to the power of x plus y. And then for a quotient rule, it's technically the same as, so instead of multiplying, we're dividing. So here it's going to be, we're going to have a to the power of x divided by a to the power of y equals a to the power of x minus y. And then we have a couple power laws. So for power, we have if we have a to the power of x in parentheses, and if you have another exponent on top of it, then both the exponents will multiply. What I mean by this is, let's say we have 2 to the power of 2, and then outside we also have a 2, right? That's kind of confusing, but we'll go by that. Then this would basically be 2 to the power of 2 times 2. So when that is because we multiply it if it comes in this format, right? So that would just be 2 to the power of 4, and then you calculate to get 16. And then we have our second power rule, which is if we have ab to the power of x outside, so if we have something like 2x to the power of 2, once again, I just want to go by 2 because I love 2. So if you have something like this, then the exponent would go to both of the bases. That means if they have two bases, then whatever the exponent is, you put that to both of the bases. So this would be 2 to the power of 2 times x to the power of 2, which is just 4x squared. And then we have another one, which this is basically power rule applied on a product, and this is power rule applied on a quotient. So if we have two different bases that are divided by each other, and we have an exponent outside of the parentheses, then the exponent goes on both the bases. So the same thing with this, if we have something like x over 2 to the power of 2, that would just be x squared over 2 to the power of 2, which is x squared over 4. So these two are pretty similar. One is about division, the other is about multiplication. Now let's go into the zero rule. So if we have an exponent that is 0, so if we have something to the power of 0, it will always equal 1. So no matter what the base is, if it's 2 to the power of 0, 3 to the power of 0, 2170 to the power of 0, it doesn't matter. It's all going to equal 1. So if I give you the biggest number, which is just keeps going to the power of 0, you don't have to do anything. Just write 1. Easy, right? And then we have a negative exponent, which is basically if we have a to the power of negative x, then that will be equal to 1 over a to the power of x. So if we have 2 to the power of negative 2, wait, let me erase this so I can clearly write it for you guys. So if we have a to the power, 2 to the power of negative 2, then this will be the same as 1 over 2 to the power of 2, which will be 1 by 4. Now we have our fractional rule. So if we have something to the power of a fraction, then that will get us into the square root format. So if we have a to the power of x over y, that would be y root of a to the power of x. And that's how you say it. So We know about square roots, we know about cube roots, but this is going to be whatever the denominator is what the root number will be, and whatever is the numerator will be what the base will be to the power of inside the square, inside the root. So for example, if we have something like, I'm not going to actually write the actual amount, but let's say we have something like 27 to the power of 6 over 7, then since the denominator is going to be the root, it's going to be 7 root of 27 to the power of 6. And that's just an example. And then you can further simplify it. If you have a calculator, use a calculator on this one, because no one's making you do that in your head. But if it's easy enough to do it in your head, such as if it was square root of something, then you can obviously do that yourself. So that's the entire plot. Now we'll get into questions.
So we have some questions to put the rules and laws into practice. So let's get started. You can pause the video now if you want and try them on your own, and unpause it so that we can look at the answers. So pause it now if you want to like practice these on your own and see if you actually understood the rules and then got it right. So the first question is 2 to the power of 1. And you know that anything to the power of 1 is going to be the number itself. Because, yeah, that's basically the rule. This is another rule. So basically, any number, it can be like x, or it can be a random number or the biggest number you've ever known. But anything to the power of 1 is just going to be itself. Okay, and so in this case, it will just be 2. There you go. Okay, and then let's look at the second question. So in this question, we have 0 to the power of something. And remember that this is another rule too. So 0 to the power of any big number, like no matter how big it is always going to be 0. Because 0 times 0 times 0 times how many times ever, it's always going to be 0, right? So it's just going to be 0. And number 3 is 1 to the power of 5. And according to our rule, remember, anything to the power of like 1 to the power of something is just going to be 1. Because let's say 1 to the power of 2, for example, it just means 1 times 1, right? Which is going to be 1, right? It's never going to change because 1 times how many ever times it multiplies by itself is always going to be 1. So 1 to the power of 5 is going to be 1. Now let's put some of the rules we learned before into practice, right? X to the power of 5 multiplied by x to the power of 10. So you know that when you're multiplying, multiply could also be like just a dot. That's another like symbol for showing multiplication. And in this case, it's 5 and 10 are the exponents, right? And then what is the rule about multiplying two exponents together? You just add them, right? So in this case, it's 5 plus 10, which is 15, and you just put the same base, and it's x, so x to the power of 50. That's your answer. So it could be any number. It could be 3, x could be any number, right? And it's just going to be the same thing. And number 5 is x to the power of 6 divided by x to the power of 3. And according to a rule, if you divide, you subtract, right? So in this case, it's 6 and 3. So 6 minus 3 is 3. So it's going to be x, because it's the same base, to the power of 3. And remember, this is really important. You can only apply these if it's the same base. So let's say if it's like 2 to the power of like maybe 5, and then 3 to the power of like 2. You cannot like divide these two and be like, oh, I'm just going to choose or multiply them and be like, well, maybe it's like 6 to the power of 3. That's not the case. You can only apply them if they're the same number. So in this case, if this was a 2 to the power of 2, then you could say, yes, I can do it because it's the same base. It's going to be 2 to the power of 3 in this case, right? Which is 8. And then now we have x to the power of 10 to the power of 2. So this in bracket and then to the power of 2. And according to the rule before, you just multiply both of these numbers. So it's going to be 10 times 2, which is 20. So it's going to be x to the power of 20. That's the answer for that one. Now, number 7 is x to the power of negative 50. Of course, you cannot find exactly because it's not a number, it's just x. But let's just write it in variable form, right? And according to the rule, it's 1 over x, and then you convert it into a positive. Because if you have anything in the negative in the exponent, remember to always turn it into positive as your answer, because that's really important in math. And since we have a negative exponent, we convert it into a positive by putting a 1 on top of it and dividing it there and putting it into the denominator with the same exponent but without the negative symbol. Now let's look at number 8. So number 8 basically says 2x equals 8. So your goal is to find x. So you can just think about it this way. I think about it this way. So how many times of 2 by itself, how many times can you multiply 2 by itself to get 8? So let's look at it, right? 2 times 2 is 4. So 4 times 2 is 8. And how many 2's do we have here? 3. So your x is going to be 3. Yes, that's simple, right? You can look at many other problems. You can go to Google and find some exponent problems related to this and practice them. And then let's look at number 9. It says 0 to the power of 8 minus 1 to the power of 56. And remember, it's kind of like a combination of these two, right? 0 to the power of anything is always 0. So here it's going to be 0. And 1 to the power of anything will be 1. So it's just going to be 1. It's just going to be negative 1. That's your answer for that. And then we have number 10. Number 10 is 8 to the power of 3 over 2. And you know from the rule we learned before that it's going to be power over root. So it's going to be 8 to the power of what? 3. And to the root of what? 2. So you can simplify that. I'm sure it's not fully simplifiable, but you can try to simplify that. And then the basic thing, the main idea here is if you have a fraction as the exponent, it's just going to be power over root, like the law Kritika was talking about. Now let's look at 11. I know this looks complicated and you're like, whoa, what are these numbers, right? So let's take it step by step, okay? First, we see a multiplication between this number, right, and this number. So let's multiply 3 and 4 together because they're numbers, right? And it's easier to simplify them. So 3 times 4 is 20. I'm just going to write it here for now. Oh, 3 times 4 is 12, sorry. And then we have x and x. So you just look for similar variable, right? And x and x. So here we have x to the power of 4, and here we have x to the power of negative 4. And you know that when we multiply, what do? We add the exponents. So 4 plus a negative 4 is just what? 0. And you know a number to the power of 0 is what? Always 1, right? So it's just going to be 12 times 1 times, let's look at y. So y is y to the power of 3 times y to the power of 3. And again, if you're multiplying exponents, what is it? You add the exponents, right? So it's going to be 3 plus 3, which is 6. So it's going to be y to the power of 6. So 12 times 1 times y to the power of 6 is what? Yes, it's 12 to the power of 12 y to the power of 6. So it's just going to be, let me write it here. 12 y to the power of 6. That's your answer for that one. If you got it right, oh my god, you got exponents, you're the best, but you still need to practice to get better. And then we have 12. Let's go. We just have 2 more. Let's go. And then we have 2 divided by 3 to the power, all to the power of 2. So from the rule before, recall that. What do we need to do? We need to distribute this exponent to both the numerator and the denominator. So it's going to be 2 to the power of 2 over 3 to the power of 2. Let's simplify this, right? Because they're just numbers. So it's 2 times 2 is 4, and 3 times 3 is 9. And then that's the answer, 4 over 9. Let's look at 13. This is quite easy, right? We talked about this before too. Any number to the power of 0 is always going to be 1. So 1 is your answer. And then 14, it's similar to this one, right? Kind of. You just distribute this exponent to all the numbers in the bracket. So here, distributed to 3, distributed to x, and distributed to the y. So it's going to be 3 to the power of 2, x to the power of 2, y to the power of, oh, look at it here. We have 5 and 2. So it's basically this format, right? What do you do when you have something like that? You multiply them both, right? So it's going to be y to the power of 10. And your final answer would be 9x squared and y to the power of 10. And that's it, guys. I hope you did really well on these questions. But if you didn't do well or you aren't that great or happy about your answers or like how many answers you got right, don't worry. Practice makes you perfect. We're this good at it because we practiced it many times and did many mathematical problems on these to get better at them. So make sure to like search up like in Google. You have many resources around you. Just use them wisely. Just search up some questions for exponents and then you can get your like practice in and you'll get better in a few days. Trust us.
So continue practicing. Like Lasta said, search up, use your resources. Guys, you have Google. You have a bunch of AIs. You can ask them for questions. Don't ask them for answers to the questions. Just ask them for the questions.
Yeah.
Okay? And we will add a picture of the rules. I did add the few that was like 0 to the power of something equals 0 and 1 to the power of something equals 1. I did add a couple of those on there too. And I did want to say that I love how Lassie explained that. And another way you can remember how to do that, to do number 8, is just make the bases the same and then whatever the exponent is what x will be equal to. And I do have that written in the rules now too, so I will put a screenshot of that at the end of the video. So that's all we have for you today. Remember, exponents are fun, exponents are crazy, and there can be a bunch of questions that can throw you off. So continue practicing like Glacia said, and we'll see you in the next video then. Goodbye.
Bye, sisters.